Hello friends, this is Chetan from GT Networks where statistics lives. Today I am going to discuss about the Kset 2024 Mathematical Sciences question paper. Here I am only discussing about the questions that is being asked in statistics part. We shall discuss one by one. Total there are 25 questions in Kset 2024 Mathematical Sciences about statistics. So we shall discuss one by one, and for your reference here I am referring to the paper code A1. Okay, so if you want to refer to the paper code, here I am referring to the paper code A1. So in the paper code A1 the 55th question is, so the first question here we have is consider a linear programming problem, that is I have to maximize z is equals to 3x plus 4y and subjected to these three constraints, and they are asking us to find the optimum solution. Okay, so we shall solve this by graphical method. How to plot the graph is, first we shall take this as x-axis and this as y-axis, x-axis, y-axis, and in the constraints what we have to do is, here let us say this is equation number 1, equation number 2, this is equation number 3. So put y is equals to 0 in this equation. So if you put y is equals to 0, x will be less than or equals to 5x is less than 200, so implies x is less than 40. So when x takes the y takes the value 0, x takes the value 40. So how to note this? Let us say this is 10, 20, 30, 40. So 10, 20, 30, 40. So this is 40 comma 0. I will call it as point A. So this is A, 40 comma 0, and here in the first equation again we have to put, what you have to put is, put here first you have to put y is equals to 0, now you have to put x is equals to 0. If you put x is equals to 0, this is 0, so it implies 4y is less than 200. So if 4y is less than 200, 4 runs 4 5s, so it is y takes the value 50. So when x takes the value 0 means it is at the origin, y takes the value 50. So it is 10, 20, 30, 40, 50. So this is 50. So this point is, let us call this as point B. So B is, let us say 0 comma 50. So 0 comma 50 it is here. This is point B. Now we shall draw a line like this and put both x and y and 0. So 0 plus 0 is 0. 0 is less than 200. So if 0 is less than 200, it is true. So then effective region is towards origin. You have to mark, you have to shade it in this format. So similarly what we shall do is, we shall put x equals to 0, y equals to 0 in other two constants and get the values. So here in equation 2, if you put y is equals to 0, so 8x is less than 80. So it means x takes, when y takes the value 0, here x will take the value 10. So when y is 0 means it is at this line, so x takes the value 10. So this is 10, 10 comma 0. I will call this as point C, and again put here x is equals to 0. If x is equal to 0, then y is less than, so 4 1s are 4 2s are 20. So when x takes the value 0, y takes the value 20. So when x is 0, y is 20. So this is 10, 20. So 20 is here. So I have to draw this line. Now put both x and y 0. 0 plus 0. 0 plus 0 is less than 80. So it is true. So the effective region is towards origin. And last point, we are having 5x plus 4y less than 100. So put y is equals to 0. If you put y is equals to 0, 5x is less than 100 means 5 1s are 5 2s are. So when y takes the value 0, x takes the value 20. So here it is 20 comma 0. I will call it as, let us say this is D, this is point D, let us say, and let us say this as point E. So this is point E, and then put x is equals to 0. So 4y is less than 100 means y takes the value 25. So 25 is somewhere here, and this is 25 and this is 20. So this is one more. And if you put both x and y and 0, y is x plus y, there is 0 plus 0. 0 plus 0 is less than 100. So effective region is towards the origin. Okay, I shall just change the color of the pen. Okay, so now you can see that this is also towards origin, this is also towards origin, and this is also towards origin, and this is the common region, area formed by the common region. So this is called as feasible region. So I will call it as, so this is origin O. O is 0 comma 0, and then this point we have 10 comma 0, 10 comma 0, and next we have this point, this one is 0 comma 20. So they are asking maximum. So then let us say this is 0.1, 0.2, and this is origin. So what is our objective function? Z is equals to 3x plus 4y. So if you put 0 0 here, 3 into 0 plus 4 into 0, that is just 0, and 0.1, that is 3 into 10. So 3 into 10 is 30, 0 into 4 is, that is 0, and this is 3 into 0 0, so 4 into 2, that is 8, so that you are getting 80. Okay, so here maximum is we are having 80, but you see here 60 is there, option 1, that is not there, 40 is there, 100 is there. So we should have got 80 as an answer, but here 80 is not there. So since 80 is not there, the answer is none of the above. So this is the answer for this question. Okay, so you may expect minimum 1 or 2 questions from linear programming problem. So most of them, they are based on the statement or they are based on the graphical method, and here they have given 2 variables, x and y. Okay, suppose if they give 3 variables, x, y, z, so then they may give this kind of problem, but you cannot plot 3-dimensional graph. So you are only having possibility of plotting only 2 dimension, that is x and y axis. So in x and y and z axis, if this problem of this kind is given, what you have to do is, here there is a thing called as primal and dual. Okay, so you have to express this problem in the form of dual. Okay, so then suppose if 3 variables and 2 constraints are given, that you can convert it to dual, and then you can only have 2-dimension graph, and then you can do that. Okay, so these kinds of questions you try to check writing the dual of the given primal problem and then solving it through graphically. Okay, so this is how you can solve the problem graphically. This is the only let us say procedure. Okay, so then if 3 variables are there, here only 2 variables x and y is given in this problem. Okay, so in the form of maybe they may give 3 variables x, y, z. In that case it is difficult to solve graphically, so then you can convert it to dual and then solve. So such problems will also be asked in general. Okay, we shall move to the next question. So here this is a direct question. What is given is, I'll just change the pen color. Okay, the point of intersection of less than Oj curves and more than Oj curves correspond to. So what do you mean by Oj curves is, so you are having less than cumulative frequency, it will be plotted like this, more than cumulative frequency, it will be plotted like this. Okay, so it will come like this, and the point of intersection, so this will be defined as median. So whatever the point of intersection of less than type and more than type Oj curves, so this exact intersection point is median. Okay, so you can see that median is option 2. So this is the right answer. Sometimes you will get direct questions, sometimes you will get let us say you have to solve. So overall you will be able to solve the questions, it will not be of that difficult. So some problems will take more than 2-3 minutes, some problems will be directly solved. Okay, so here by just, if you just know the result, directly you can put this answer. And one more thing you have to remember in the competitive examination is, suppose you are solving a question, difficult question, first question is there, let us assume. Okay, and it is very difficult to solve. So you are taking, let us say, 5 minutes or 10 minutes to solve this problem, and ultimately you are getting the right answer, let us assume. Okay, but you have invested this much time to get this answer, and let us say one more question is there, directly you know based on the result you are going to solve. Okay, so here also, here you are not using like 5 or 10 minutes, just maybe 2-3 seconds or maybe within 20 seconds you are going to answer. So here also you are getting the right answer, here also you are getting the right answer, but marks awarded is here also you are getting 2 marks only, and here also you are getting 2 marks only. Okay, whether you are investing long time or short time, if you are getting the right answer, the marks awarded is only 2 marks. So that you have to keep it in mind. So in the first go, what you have to do is, so whichever questions are easier and whichever questions will demand lesser time, so if it is maybe if you are able to correct that, if you are able to do that in the lesser point of time, so try to attempt those questions first, and later you will be left with time, then you can do this all algebra and then get the right answer for the next questions. So beginning only, if you are using 5-10 minutes for only single question, then you will not be left with much time for later simpler easier questions. Okay, so this is the strategy that you have to adopt. Fine. So here this is again a direct question. It is these 2 questions 56 and 57, these are just based on BSc statistics knowledge. You need not require much let us say the special knowledge of statistics. And one more thing is, here I am from the background of statistics. I'll be doing only video for statistics students. Okay, so those who are from mathematics background, they can also follow my videos and they can also follow these lectures, so that they can also somewhat clear these questions with the simple let us say with no special knowledge, I can say. Okay, so here what is given is y is equals to 2x minus 20, then mean of y values will be, and they have given x bar is equals to 10. So we have expectation of, means if they have given x bar, it is nothing but expectation. Okay, so x bar is equals to expectation of x, so this is equals to 10, that is given to us. And what are the results we are having is, in terms of expectation of ax is equals to a into expectation of x, where a is constant. Okay, if a is a constant, then you can write expectation of ax is a into expectation of x, and expectation of a is equals to a itself if a is constant. So whenever a constant is there, if you are taking expectation, it is just the constant only, so that you are having. So we shall apply this expectation of y, because they are asking the mean of y. Mean of y means expectation of y, so that is equals to expectation of 2x minus 20. So using these two results, I can write 2 into expectation of x minus expectation of 20 is just 20, because it is a constant. So 2 into expectation of x, they have given expectation of x as 10 minus 20. So 2 into 10 is 20 minus 20, the answer is 0. So you can see that option 3 is there. So this is the correct answer. Okay, we shall move to the next question. So very simple questions are there, you can answer this. Next, question number 58. The joint probability density function of two random variables x and y is given by, so they have given f of x comma y as f of x plus y, and the range of x is, so here f of x is x comma y is given as x plus y. Y takes the value, x lies between 0 and y, and y ranges from x to y. Okay, so you can see this, the range of x is 0 to y, so that I have written here, and the range of y is less than or equals to 1, that is written, and you see that y is just greater than or equals to x. So using this we shall solve this problem. They are asking marginal density of x. So marginal density of x is f of x is equals to integration of f of x comma y dy. So because we want f of x, so we have to integrate with respect to y. Okay, and what is the range of y? The range of y is it ranges from x to 1. So lower limit is x, upper limit is 1. So that is equals to x to 1. F of xy is, it is given as x plus y dy. So now we have to integrate this with respect to y. So integration of x dy, I will write it like this, x to 1 x dy plus integration of y dy, integration running from x to 1. So if you simplify this, so integration of x, since it is a constant, it is just x only. Integration of dy with respect to y is y, and limit ranges from x to 1, plus integration of y with respect to y is y square by 2, and the limit ranges from x to 1. Okay, so further if you simplify this, so that is equals to x into, so upper limit is 1, lower limit is x, so 1 minus x, plus upper limit here it is 1 minus lower limit is x square whole divided by 2. Okay, so simplify this, what is that, we will get, I will write it here, x into 1 is x minus x square plus 1 by 2 minus x square by 2. So here I shall take it as minus 3x square by 2 and plus 1 by 2, and this is x as it is. This I am keeping it as it is, minus x square by 2, that is minus 3x square by 2 plus 1 by 2. So you see that option 3 matches this. Okay, so therefore this is the right answer. This is the right answer. Very simple, what is that, algebraic simplifications, you are going to get the right answer. Only thing is you should know the result behind this. So based on probability also many questions will be asked. We shall see what all questions has been asked. Next, question number 59. Here it is a direct result. What is given is the condition for xn divided by yn, this is converging in probability, this is weak law, to x divided by y is. Okay, so we have, if xn converges to x and yn converges to y, okay, xn divided by yn, this will also, this convergence in probability, this will converge in probability to x by y if two cases happen, what is that is probability of yn taking the value 0 should be 0. It means that yn should not take the value 0, because what do you mean by this probability of this happening is 0 means this is not happening. Okay, so always you know that probability lies between 0 and 1. Okay, so if probability of any event A is 0 means that event is not happening. Okay, so here y should also be not 0. If y is 0, what will happen? X by 0 is infinity. Okay, it will not converge to x by y, and yn should also not take the value 0. It should also not take the value 0, because xn divided by anything that is 0, if yn takes the value 0, then this itself will be infinity. Okay, so then this condition will not hold. Okay, this condition will hold only when y should not take the value 0 and yn should not take the value 0. You see the options, option 2 is there. Here yn taking the value 0, this probability is 0, and y taking the value 0, this probability is also 0. So the option is, the correct answer is 2. Okay, so directly you can answer this without any mathematical simplification. Shall move to the next question. Okay, so here the transition probability matrix of a Markov chain is given, and you may expect minimum 2 questions. So maximum maybe 4 questions might also have been asked. So minimum 1 or minimum 2 questions will be there in the Kset. Earlier the Kset pattern was, so in mathematical sciences, total 100 questions. Out of 100 questions, and Mysore University was conducting the Kset examination, there 60 questions of mathematics was asked and 40 questions of statistics were asked. So this was the pattern earlier. So now KEA is conducting examination. So here they have divided all the 4 units into 25 each. Okay, so you are only getting statistics, 25 questions from statistics. So those who are willing to clear Kset from statistics background, they have to concentrate on linear algebra and real analysis. So here some 25 questions you may get, or more than that you may get, that you have to check. Okay, so this background you will be having in your MSc. So by combining this you may clear the examination very easily. Okay, maybe during the end of video I will show the cutoff and how to clear the strategies also. I will speak maybe in the next video or in the later part of this video. Okay, so here what is given is Markov chain is given. If the transition, what is this TPM? TPM is a matrix. Okay, transition probability matrix. Here the entries of this matrix will be probabilities. Okay, so this will always be greater than or equals to 0 and less than 1. Okay, less than or equals to 1. So the entries will be less than or equals to 1 and row sum will be 1. So that matrix is called as transition probability matrix. So here they have given a transition probability matrix, and they are asking us to find the steady state distribution. So to find the steady state distribution, there are many properties. You may see my previous videos. I have a playlist of Markov chains. Okay, so there you may observe many results. Using the results also you can directly solve, but here it is not based on the result. There is a thing called as doubly stochastic matrix. Doubly stochastic matrix. So what do you mean by doubly stochastic matrix is always row sum will be 1. That is why you are calling it as transition probability matrix. That is there. If row sum as well as column sum, if both are 1, then the matrix is noted as doubly stochastic matrix. So here you see the column sum 0 plus 1 by 2 plus 1 by 2, this is 1, and here it is 2 by 3 plus 0 plus 1 by 2, this is not 1. Okay, so this is not equals to 1 and this is also not equals to 1. Therefore it is not a doubly stochastic matrix. The result is, if the transition probability matrix is doubly stochastic. Doubly stochastic means both row sum and column sum should be 1 for all the states. So then the transition probability is 1 upon n times. This is the result. Okay, so you may get those questions also. Those questions also have appeared in Kset as well as net, so that you can check. Okay, so for example, I will solve this example by giving one simple example. Suppose this is the transition probability matrix, 1 by 2, 1 by 2, and then this is 1 by 2, 1 by 2. So then what is the transition steady state distribution of this is, here row sum is always 1, therefore you are calling it as transition probability, and here you see the column sum 1 by 2 plus 1 by 2 is 1, 1 by 2 plus 1 by 2 is 1. So then this matrix is called as doubly stochastic matrix. So in that case the transition probability is 1 upon n. So here n is state 1, state 2, so total two states are there. So 1 upon 2 is your steady state distribution. That is the direct result, but here it is not the case, we have to solve. So how to solve this what is that transition probability matrix to get the steady state is, so the formula is, okay, so this question will be solved in this format. The formula is pi dash into p minus I is equals to 0, and one more result is pi 1 plus pi 2 plus pi 3, so this is equals to 1. Okay. we shall solve this. Pi dash is, it is a row matrix, pi 1, pi 2, pi 3, and P is this is transition probability matrix, and I is identity matrix of order 3 by 2, 3 by 3. Okay, so if you subtract this P minus I, what you will get is, here it is minus 1 in the diagonal entries, and rest entries are as it is, 2 by 3, 1 by 3, 1 by 2, 1 by 2, and this is again 1 by 2, 1 by 2. So this will be equals to 0. So now if you multiply this row and this column, so you are having minus pi 1 plus pi 2 by 2 plus pi 3 by 2 is equals to 0. So this implies I shall write it as pi 1 is equals to pi 2 plus pi 3, and this whole by 2 I will write it as 2 here. Okay. Next one, 2 by 3 pi 1 minus pi 2 plus pi 3 by 2 is equals to 0. So this implies pi 2 is equals to pi 1, this is 2 by 3 pi 1 plus pi 3 by 2, and last equation is 1 by 3 pi 1 plus 1 by 2 pi 2 minus pi 3 is equals to 0. So this implies pi 3 is pi 1 by 3 plus pi 2 divided by 2. Okay, so we are having this, I'll call it as equation star and call it as equation number 1. So pi 1 plus pi 2 plus pi 3, pi 2 plus pi 3 is 2 pi 1 is equals to 1. So I am substituting pi 2 plus pi 3 from the equation number 1 to equation number star. So 2 plus 1 is 3, so implies pi 1 is equals to 1 by 3. So if pi 1 is 1 by 3, option 1 and 2, so these 3, 4 are ruled out. Now we have to see between these options. Okay, fine. We shall just verify this, whether 1 by 3 plus 2 by 3 plus 1 by 2, is it equals to 1? Let us check. Okay, so this is 1 by 3 plus, this is 3 by 3 plus 1 by 2, this is 1 plus 1 by 2, this is not equals to 1, but what you have the result is pi 1 plus pi 2 plus pi 3 should be 1. Okay, so check the option number 2, that is 1 by 3 plus 10 by 27 plus 8 by 27, is it equals to 1? Let us check. So the common denominator is 27, so I will multiply by 9 and divide it by 9. So common denominator is 27, then we can add this 10 plus 9 plus 8, that is 27. So 27 by 27, this is equals to 1. So option 2 is the right answer. Okay, you can also verify this, that is you can by putting pi 1 in this equation, in these two equations, and expressing pi 2 in terms of pi 3, pi 3 in terms of pi 2, you can resolve this and you can solve, then also you are going to get the same answer. Okay, so in the competitive examination we shall see the shortcuts and then try to solve it in the simpler manner. So this is how we can solve. Okay, so if you just get one steady state, then you can just rule out other options. Fine. Next question, question number 61. So here we are given a persistent state of a Markov chain is said to be null persistent if its mean time is, okay. So and the mean time, what do you mean by persistent state is, it is nothing but recurrent state. Okay, in recurrent state there are two types, one is positive recurrent, another one is null recurrent, and they are asking what is its mean recurrence time. So if mean recurrence time is less than infinity, then that recurrent state is positive recurrent, and if it is exactly infinity, then it is a null recurrent. Okay, so a persistent state of a Markov chain is said to be null persistent. So persistent recurrent, both are on the same, so the option is 1. So infinite, that is the answer, option 1. Next question, here we are in question number 62. Okay, so here what is given is steel rods are manufactured to be 3 inches in diameter. So steel rod is there and the target is, the diameter is 3 inches, but they are acceptable if they are between 2.99 inches and 3.01 inches. So this is acceptable only if the diameter falls in this interval. 5% are rejected as overall size and 5% are rejected as undersize. So here overall size, no, it is oversize. So if the diameter is more or if it is less, then 5% are rejected. Assuming the diameter is normally distributed, the standard deviation of the distribution is given by. So they are asking the standard deviation. So we have here in this question xi, this follows normal distribution. Xi is the diameter of the rod. So this is normally distributed with mean mu and variance sigma square. So this variance is unknown to us, that we have to find. Okay, and they are giving that the steel rods are manufactured to be 3 inches. So they have given the target that this mu is 3. Okay, so here xi follows normal distribution with mean 3 and variance sigma square, and we know that. So here they have given the size of the test, that is they are rejecting at 5%. So probability of if x is taking the value more than 3.01, then you are going to reject with this with 5%. So this is 0.05. So we shall standardize this. Probability of x minus, I'll subtract mean and divide it by standard deviation. This is greater than 3.01. So here I have subtracted by 3. The same I will do here and divide it by sigma. So this should be 0.05. Okay, 5%. So x minus 3 by sigma, this is standard value. So this is z greater than 3.01 minus 3, that is 0.01 divided by sigma. This is equal to 0.05. And we know that here the value of, that is probability of z greater than z alpha, if it is to be 0.05, then the value of z alpha is 1.645. Okay, so this is a well-known result. Okay, so 1.96 is there, minus 1.96 plus 1.96, and then 2.53. so these are constant standard values. Okay, so this is a two-tails test because they are rejecting on the either side. So the value of z alpha is 1.645. Okay, so 0.01 divided by sigma is equals to, so this I am equating, these two I am equating. So this is equals to z alpha, and z alpha is 1.645. So sigma is equals to 0.01 divided by z alpha is 1.645. So this 1.645, what we shall do is we shall multiply this upper limit, numerator by 1000. So this will be 1. So 1, 2, 3 digits I will shift, and then here also we shall do the same, or else multiply this by let us say 100, and here also 164.5 you will get. Okay, so 164.5 I can approximate it to 165. So here I will shift 2 digits, here also I will shift 2 digits, it is 164.5, approximately 1 by 165. You see the option 3 is there, that is matching this. So option 3 is the right answer. So before going for the examination, we just look at these constants. Earlier these kinds of questions were not asked. Now based on these constants also they are asking. So better to remember these normal constants. Next, question number 63. The ratio of two chi-square variates with respective degrees of freedom, that is n1 and n2, is distributed as. So this is a direct question. If I shall just tell you previous to this, if x follows normal distribution with mean mu and variance sigma square, then x minus mu by sigma, we will call it as z. Okay, this again follows normal distribution with mean 0 and variance 1. So this is called as standard normal variate. Okay, and the result is if you are taking the square of standard normal variate, okay, this follows chi-square distribution with 1 degree of freedom, since you are only having one variable. Suppose if you are having n variables, then this will follow chi-square distribution with n degrees of freedom. Okay, and here what is given is two chi-square variates. Here x1 itself is a chi-square variate, it is following chi-square distribution with n1 degrees of freedom, and x2 is also chi-square variate with n2 degrees of freedom. Okay, and they are asking the ratio of two chi-square variates. So we know that ratio of two chi-square variates x1 by x2, this follows f distribution, okay, with degrees of freedom n1 and n2. Okay, so this is a known result and it is a direct answer. So you can get this answer, you can mark this directly. Okay, and one more is here gamma is there. So if x follows exponential distribution, then sum of this x follows gamma distribution. So these are some simple results. That is the relation between the distributions that you should be knowing. Okay, we shall move to the next question. Question number 64. So here the question is about x1 and x2 are independent and identically distributed. So x1, x2, these are independent and identically distributed. For they are distributed as Poisson variates. So the parameter is theta. which of the following statistic is sufficient for theta. Okay, so we know that by Neyman-Pearson factorization theorem, so if you are able to write any PDF or PMF of f of x theta as h of x into g theta of tx, if you are able to write in this form, then this tx will be your sufficient statistic for this parameter theta. Okay, we should be able to segregate the sufficient statistic and function of theta as one function, and h of x is just a function of sample observation. Okay, so here what is f of x, or you can say p of x, that is e to the power minus theta, theta to the power x by x factorial. Okay, so here you are having two variables, so this is, let us say, f of x1, I'll write 1 here, and f of x2 is e to the power minus theta, theta to the power x2 divided by x2 factorial. Now here, since x1 and x2 are independent and identically distributed, f of x1 x2, this can be written as f of x1 into f of x2, so that is e to the power minus 2 theta, theta to the power, so base is same, power can be added, x1 plus x2 divided by x1 factorial into x2 factorial. So this I can write it as, this factorial term I'll write here, x1 factorial, x2 factorial I'll write here. Okay, e to the power minus 2 theta, it is independent of x, so theta to the power x1 plus x2. So using this theorem, so this is h of x and this is a function of g theta tx. So here tx is nothing but x1 plus x2. Okay, so you can take e to the power minus theta in this itself. Okay, so this is a function of theta as well as tx. So here tx is in the form of x1 plus x2, then this tx will be sufficient statistics. Now you can see where is that x1 plus x2, so this is here. Okay, so this is the right answer for this question. I shall move to the next question. So here they have asked about find the lower bound for the variance of unbiased estimator of the parameter theta for the density. So this is a Cauchy distribution. The given distribution is Cauchy distribution, and they are asking us to find the lower limit of lower bound of variance of the unbiased estimator. Suppose theta is there and t of x is unbiased estimator of this theta, that is expectation of tx is equals to theta. We don't know what is this tx. Okay, and what is the lower bound for the variance? Variance of this tx is greater than or equals to what? Okay, so they are asking this. So what we have, the formula is this variance of this t of x, it is always at least means the CR lower bound, Kramer-Rao lower bound, so that is just greater than 1 upon Fisher information. So variance of t of x, if t of x is unbiased estimator of theta, then variance of t of x is greater than or equals to 1 upon Fisher information contained in this theta. Okay, for n observations. So now we shall just check the Fisher information for this given distribution. So we shall write log of this L is equals to, let us say L is equals to, sorry, I'll go to the previous question. Okay, so L is equals to log of f of x comma theta. So that is equals to, if I take the log for this, minus log pi minus log of 1 plus x minus theta whole square. So this we have to differentiate. What is the formula for Fisher information? I1 of theta means Fisher information for one sample, that is expectation of dou L by dou theta whole square. Okay, you have to differentiate this L with respect to theta and then take the square of that you have to take the expectation. Okay, so this is L. I'll differentiate this L with respect to theta, dou L by dou theta is equals to, this is independent of theta, so this will be 0, minus 1 upon 1 plus x minus theta whole square, and then internal differentiation, and differentiation of 1 is 0 plus x minus theta whole square is that is 2 into x minus theta, and differentiation of minus theta is minus 1. So this will be minus into minus, that is plus 2 x minus theta divided by 1 plus x minus theta whole square. Okay, so we have to take the expectation of this, square of the expectation of this, expectation of dou L by dou theta whole square we have to do. So expectation of dou L by dou theta is 2 x minus theta divided by 1 plus x minus theta whole square. So this square we have to take the expectation. So we know the formula for expectation, that is if expectation of any function x is there, that is integration of x into f of x dx. Okay, so this we have. So instead of x, in the place of x we are having this entire term. So this is equals to expectation of I shall write the integration of, I just erase this part. This is nothing but integration of x into p of x. So instead of x we are having this 2 times x minus theta divided by 1 plus x minus theta whole square, this square into f of x dx. Instead of f of x we are having this 1 upon pi into 1 plus x minus theta whole square with respect to x. Okay, we are having this. So instead of finding z, and this ranges from minus infinity to plus infinity, so we have to solve this. 2 by pi, it is constant, it will come outside the integration, and we have to square this and then find the integration of this term. Okay, so for simplification we shall put x minus theta is equals to, let us say, z. Okay, if you put x minus theta is equals to z and then simplify this, so what we will get is this I1 of theta, we are getting this as I1 of theta is equals to 1 by 2, and IN of theta is equals to n into I1, so that is n into 1 by 2, that is n into 1 by 2, that is n by 2. The answer is n by 2. So we are having 1 upon IN of theta, so 1 upon n by 2, so that is equals to 2 divided by n. So the answer for this equation is this question is 2 by n. So you have to put x minus theta is equals to, let us say, z, and this is a even function. Okay, so if even function is there, you can split the integration from minus infinity to plus infinity as 2 times 0 to infinity. Okay, this you have to split and then solve. We have to use this beta distribution, beta function approximations you have to use, and then we will solve. So after solving this, you are getting this as I1 of theta, you are getting it as 1 by 2. So IN of theta is n into 1 by 2, that is n by 2. So reciprocal of that is 2 by n. So the answer is 2 by n for this question. Next, 66, question number 66. So here they are asking to find the best critical region. So best critical region is given by here the formula, the hypothesis given is h naught theta is equals to theta naught. H naught theta is equals to theta naught, that is simple null versus composite alternative. Okay, so we shall solve this question. Let this be the last question of this part of the video, and remaining questions I will solve it in the next video. Okay, so here we are given h naught theta is equals to 0 versus h1 theta is not equals to 0, and f of x comma theta is given as 1 plus theta square. Okay, so under h naught, what is the value of theta? Theta takes the value 0. So under h naught, if you substitute theta is equals to 0, 0 into anything is 0, so f of x theta is just 1. Okay, and you see x lies between 0 and 1. X lies between 0 and 1. What is this? This is nothing but uniform distribution. Okay, and under what is that, h1, and one more thing you see, 0 is less than or equals to theta, theta is less than or equals to square root of 2. You can see that theta is always greater than or equals to 0. Okay, and what is h1 here? H1 is theta is not equals to 0. So this means that, and theta is greater, and here we see the range of theta is greater than or equals to 0. So this hypothesis will be turned out as h1 is theta is greater than 0. Okay, you can convert this to this hypothesis. How? See, h naught theta is equals to 0, that is null hypothesis. Theta is not taking the value 0, that is alternative hypothesis, and we see that theta is always taking the value greater than or equals to 0. Okay, so if theta is taking the value 0, that is covered under null hypothesis, and if theta is positive, that is covered under the alternative hypothesis. That is what is given here. Okay, so this problem boils down to h naught theta is equals to 0 versus h1 theta is greater than 0. In order to solve this, we have the theorem called as Kerlin-Rubin theorem. Okay, in Kerlin-Rubin theorem, what they will do is they shall find the monotonic likelihood ratio test. So how to do that? Let theta 2 be greater than theta 1. Okay, and for any what is that, theta 2 greater than theta 1, whether this is increasing function in tx. Okay, if it is increasing function in tx, then we can write the test function. So how to write that? First we shall see whether it is monotonically increasing or decreasing. Okay, so f of x comma theta 2 divided by f of x comma theta 1. So this is equals to, so put theta 2 in this equation, 1 plus theta 2 square x minus 1 by 2. Here 1 plus theta 1 square x minus 1 by 2. Okay, we have seen that theta 2 is greater than theta 1. So in order to check, so let us take theta 2 is equals to 1, because square root of 2, that is more than 1. So let us take theta 2 is equals to 1, and here theta 1 is less than 1. Let us take theta 1 is equals to 0.5. Okay, we shall substitute in this equation 1 plus, here theta 2 is taking the value 1, so it is just x minus 1 by 2 divided by 1 plus, here theta 1 is 0.5, that is 1 by 2, so x minus 1 by 2 whole divided by 2. Now whether this is increasing in x or not, we have to see. Okay, in order to see that, x takes the value 0, 1 or any value between 0 and 1. Let us take x1 and x2. Okay, x1 less than x2. x1 is equals to, let us say 0, and x2 let us take it as let us say 1. Okay, 0 to 1, that is the maximum limit. So here, and x takes the value, let us write it as lambda of x. Okay, so lambda of 0 is equals to, so when you put x is equals to 0, 0 minus 1 by 2 is minus 1 by 2. So 1 minus 1 by 2 is 1 by 2 is the numerator. And here if you take 0 here, 0 minus 1 by 2, that is minus 1 by 2. Minus 1 by 2 whole divided by 2 is minus 1 by 4. 1 minus 1 by 4 is 3 by 4. So this turns out to be 2 by 3. And put x is equals to 1. So lambda of 1 is equals to, if you put x is equals to 1 here, 1 minus 1 by 2 is 1 by 2. 1 by 2 plus this is 3 by 2. And here it is 1 by 2. 1 by 2. 1 minus 1 by 2 is 1 by 2. 1 by 2 whole divided by 2 is 1 by 4. 1 plus 1 by 4. 1 plus 1 by 4, that is 5 by 4. So 5 by 4. 2 ones are 2 2s are. 2 goes numerator, 6 by 5. So this is lambda of 1. So 6 by 5 is 1 plus 1 point something. Okay, and this is 0 point something. So when x1 is less than x2, this lambda of x1 is also less than lambda of x2. So this is monotonically increasing in x. Okay, so since this is monotonically increasing in x, I shall erase this. So what we can write is, the test function is given by reject, that is test function pi of x is equals to reject h naught with the probability 1. If t of x is monotonically increasing, this is t of x is greater than some constant k, or 0 otherwise. Okay, this is the or that test function based on Kernel-Rubin theorem. And here tx is x. In this case we have tx is x, because this f of x of theta 2 divided by f of x comma theta 1, this is monotonically increasing in x. Okay, so in general it is increasing in tx, but for this equation, for this question, you are having this is monotonically increasing in x. So therefore we shall replace this. So pi of x is equals to 1 if x is greater than k, and 0 otherwise. So we have, they have given that the size of the test is 0.2. So expectation of pi of x under h naught, this is equals to alpha. Okay, this is at most alpha. So expectation of pi of x is equal to alpha means, so take the expectation of this. Expectation of pi of x is equals to 1 into probability of this. So 1 into probability of x greater than k, this is equals to alpha, plus 0 into other is, that is 0. Probability of x greater than k, this is equals to alpha is given as 0.2. So that is 1 minus probability of x less than or equals to k is equals to 0.2. So this implies probability of x less than or equals to k is 0.2. Okay, just a second. Okay, so probability of x less than or equals to k is 0.2. Sorry, 0.8 we will get if you send it to the other side. I shall just check this. Okay. So this will be 0.8, because this implies probability of x less than or equals to k is 1 minus 0.2. Okay, so x less than or equal to k, this is under h naught. So we know that under h naught, what is this? F of x comma theta is equals to 1. So this is uniform distribution. I shall erase this. So this is 0 to uniform distribution, x takes the value 0 to 1. Okay, so here property of x less than k we want. So 0 to k f of x dx, this is equals to 0.8. so f of x is, for this we have 1, so that is k is equals to 0.8. directly you can get that. And they are asking the best critical region. So the power of the test is given by expectation of pi of x. I shall erase this part. Expectation of pi of x is equals to, just a second, I'll erase. Expectation of pi of x under h1. So this is nothing but power of the test. Okay, so which one is having more power, that is what is the best critical region. So that is equals to, so what is pi of x? Pi of x is 1 if t of x is x here, if it is greater than k is 0.8 and 0 otherwise. So expectation of this is 1 into probability of x greater than or equals to 0.8. So you can include this equality greater than or equals to here or here, since it is a continuous distribution. So power of the test is equals to, power is equals to, what you have got is probability of x greater than or equals to 0.8. Now you search this in any option. So this is not, see option 3. So this is the correct answer for this question. Okay, so this is based on Curlin-Rubin theorem, uniformly most powerful test. So in MP and UMP you might expect one question. Okay, so thank you friends, thank you for watching this video. I shall upload one more part 2, solving remaining questions of Kset 2024 statistics part. Thank you, have a nice day.